In this video, we are going to explore some data on opioid overdose deaths. In 2010, PA had 629 opioid overdose deaths. In 2012, Pennsylvania had 827 opioid overdose deaths. We are asked to write a y equals mx plus b model to estimate the number of opioid overdose deaths in Pennsylvania since 2010. So some very sobering numbers to work with. But I do see that in writing a linear model, they are giving me data that appears to be ordered pairs, and that is going to be helpful as I try to come up with some algebra that's going to capture this data. So the first group of numbers that goes together is 2010. And Pennsylvania saw 629 deaths due to opioid overdoses that year. And then in 2012, that number increased to 827. Now, we had seen in our pre-lecture that when we're dealing with the year, we want to renumber those years because this issue of opioid overdoses has not been going on for forever. So specifically in the directions here, it says to estimate these for Pennsylvania since 2010. So that is telling us to use 2010 as our starting year. And so that allows me to rewrite these ordered pairs. 2010 is year 0. And then 2012 would be year 2, 2 years into the data or into the trend. So in order to write a linear equation, the first thing that I need to do is I need to figure out slope or rate of change. And I do that using the slope formula. So we have that slope is y2 minus y1 over x2 minus x1. And our ordered pairs are x and y ordered pairs, and the first one will give the little subscripts 1, and the second one will give the little subscripts 2. So plugging those numbers in, on the top I have 827 minus 629. In the denominator I have 2 minus 0. Doing my math for those, I get 198 over 2. And dividing that out, I get 99. And so that is my slope, that's the m. I like to put some labels on that so that I'm understanding that, and that would be deaths, because we have our top number of deaths, and that would be per year. So what this slope is telling me that since 2000, the number of deaths are increasing by 99, almost 100 additional deaths per year. So that's the first step in writing my slope, or writing my equation. I've found my slope, and so far in my equation I have y equals 99x plus b. And so in order to finish that equation, I need to fill in b, and we have to think about, well, what is b? B is the starting amount. And because we were given time, and because we were told to start in 2010, we know the starting amount, and we see that in this ordered pair here, where we started that ordered pair at 0, and so in 2010 we started with 629 deaths. And so that gives me an equation, y equals 99x plus 629. And this equation will allow us to predict how many deaths from opioid overdose there were in Pennsylvania each year. So I am going to clear my screen and erase all of this so we have room to start the next problem, but we are going to use this answer over again. So give me a moment. And now we'll start over with our formula from the first step, and that is y equals 99x plus 629. So it asks us as our second bullet point here, in what year does your equation predict that the number of deaths will be greater than 1,000? So because this 1,000 is a number of deaths and my equation predicts the number of deaths, I'm going to put that in as a y value. So I have 1,000 is equal to 99x plus 629. I'm going to need to do some algebra in order to figure out what x is. So the first step of algebra is to subtract 629 from both sides of my equation. And that gives me 371 is equal to 99x. My second step of algebra is to get x alone, and so I want to divide by 99 because I always want to do the opposite on both sides. And again, this gives me x, and with the help of my calculator, and I did round this number off, I got 3.7. So I have to think through, well, what does that mean, and does that answer the question? And we're certainly on the way to answering the question, but we also are not quite there. So this is the x value, and x is our years, and specifically this is going to be the years since 2010, because we had 2010 as our starting point. And so it asks me in what year. So I'm going to take 2010 and I'm going to add the 3.7 to it, and that's going to give me 2013.7. And since we don't really talk about years with decimals, I'm going to round that to the nearest year, which would be in 2014. So in answer to the question, in what year does my equation predict that the number of deaths will be greater than 1,000? That would happen in 2014. And because this is historical, I used the website listed below there and looked up that number, and in 2014, Pennsylvania had 1,092 deaths, and that was the first year that more than 1,000 people in Pennsylvania died of opioid overdose. And so our equation makes an accurate prediction of what really happened. And that is the whole point of creating a model, is to use it to accurately predict and then prepare for what's going to happen. So again, I'm going to erase my workspace here, and then we'll go on to the third question. So what we already know is that we know our equation is y equals 99x plus 629. And we know that this happened in 2014. Our next question is asking us to use our equation to estimate the number of opioid overdose deaths in PA in 2016. And so first thing I have to do is figure out what number I'm going to use to represent 2016. We use 2010 as our starting, and so I will subtract that out, and that gives me 6, and so this is year 6 in our data set. So I will take that. I know that x is my time or my year, and I know that from the very first ordered pairs where I put the year as the x value in those ordered pairs. So I'm going to use y equals 99 times 6 plus 629. And this is math that my calculator handles for me. So I go to my calculator and I type 99 times 6 plus 629, and I get y equals 1,223. So that is my answer. But now, again, because this is historical data, I wanted to look at, well, what was the reality? And the actual number of deaths in Pennsylvania in 2016 was 2,235. And so my prediction is significantly different than the reality. It's off by 1,000. It's barely more than 50% of what actually happened. And so this, I am just making a note here, is not a good prediction. Or we could say not a good estimate, because this is historical, so we're no longer predicting it, but estimating it. And so then the last question we have is, do you think your equation would be good for predicting the number of opioid overdose deaths in Pennsylvania for 2020? And the answer that I would give is no. And the reason, the why or why not, is because our linear trend no longer worked already in 2016. And then I have two websites listed here. The first one is where I got the numbers. So the numbers for 2010, 12, 14, 16, all those numbers that we compared with are from the first website. The second website provided a graph, and I felt like this graph was incredibly helpful in seeing why our numbers were off and what was going on. So let me bring that into our viewing screen here. And so on this graph, it starts in 1999 and it goes through 2021. And we're going to look at the top line here, which is in black because that is the total. And when I look at this from 1999, the whole way up to about 2013, the line, the black line, appears to be a line, to be linear. And that's where we started at 2010, and we were looking at an equation for that line, and we found that the data and our predictions or estimates were really close because the data was very close to a line. It's not perfectly straight, so it's not a perfect estimate, but very close. From 2013 on is when we saw the rise in synthetic opioid overdose deaths. And so this is when fentanyl really hit the market and it had a huge increase in deaths. And so we don't see the line continuing. Instead, we see that there is a curve to it, which would be much more like an exponential model where we have that curvature. And then we do see a little flattening, and again, these going up really high with the pandemic. So not only in answering our last question, does the data no longer fit the line, but in 2020, with the pandemic, we have a change in our culture and our history that would also make any previous estimate off. So we have two reasons that we could use for why we cannot use this to predict 2020. So if we go back and add based on the graph, so no, I don't think it's good at predicting because the linear trend no longer fit the data. And also there was the pandemic. And so what we see in healthcare especially is that we watch trends because trends are going to impact how many beds we need, how much staffing we need, and how much meds we need to stock, and all of the how much meds needs to be produced. So they have a lot of impact on the healthcare industry. But then there are things outside of what we have captured in our equation that can impact this. So our equation y equals 99x plus 629 would have been great up until fentanyl hit the market. And then that changed the parameters and that changed the number of opioid overdose deaths. And then again, we could have used an exponential curve to start capturing the data, but again, it changed once the pandemic hit because that was an outside influence. And so there are limitations to using algebra for prediction, and that's why we continue to collect the data, compare it to what we expected, and look at everything that's happening around us to see whether or not we can continue to use our model for a prediction.